Hello guys, welcome back. In this video, let us understood how to compile a neural network based ML model to understand the accuracy by using a validation data set, and how to train a model and how to find the accuracy of our model before training as well as after training. That is, in this video, we will understood how to measure the accuracy of a model. Currently, our model is a neural network based ML model. That model accuracy we are identifying. So in order to identify the accuracy, we first need to compile our model before training our model. There, while compiling, we need to mention metrics like accuracy. So if we mention the metrics like accuracy while training our model, so since we represented or since we mentioned accuracy metrics while compiling, that accuracy score will be shown to us while training our model with some validation data. That validation percent also we need to provide. So after training our model, we also check how to find the accuracy of trained model with some test data set. So what are the two major accuracies we are finding while training our model? While training our model, we will identify the accuracy by using validation data set. Whereas after training our model, we again find the accuracy of our model with respect to test data set. Now let's see hands-on how to do this. Now let's continue from previous steps. That is after data pre-processing step. Let's continue with it. So those who watched the previous video of data pre-processing, they know how to pre-process a CSV file data. So after that, we are continuing. So I'm just commenting all the other steps like loading our model as well as different layers which are present in it. So now actually we'll perform the task. Like now let us build a model. Those who watched the previous videos, they already know how to build a model. So actually we need to import two things while building a model with neural networks. Those are we need to import models as well as layers. These actually present in TensorFlow.keras library. So I'm just importing these two from there. Then let's create our model or let's build our model. Our model is nothing but by using the models, we need to create a sequential list of layers. So first layer is nothing but input layer. We define that input layer by using either feed forward network or directly by using input layer. Currently, I want to define it by using feed forward network. So I'm using a dense. And so for this layer, currently I want to put 64 neurons in the first layer, and my input shape of this layer, I want to provide. Since it's a input layer, we need to provide this input shape. What is our input? X underscore train. This is nothing but our input. So that shape I need to provide. In order to provide that shape, capital X underscore train of train dot shape is the function, is the method that I need to use, and of one can provide me the actual shape. This is just the input layer. And here I want to remove the non-linearity as well. So I'm providing the activation function, that is ReLU. That is nothing but regularized. That is nothing but linear unit. That is this is nothing but ReLU. That is a rectified linear unit. I want to use this for providing non-linearity. So that's why I'm using it again in hidden layer. I want to provide one hidden layer. I provided already the input layer. Now I'm providing the hidden layer with some activation function. That is again ReLU I'm using to introduce some non-linearity. So that's it. And I want to provide the output function. So I want my output to be actually for classification, like whether a person can able to survive or not based on that data set. I have provided a data set, and then in that data set, based on the input features that I'm providing, I need to predict my output, like whether a person can able to survive or not. That output I want to predict. So that's why in order to classify, since we are predicting whether a person can able to survive or not. So since it's a classification task, I'm using a dense layer. I'm using a feed forward layer, that is a dense layer, with output neuron, only one neuron with some activation function. That is, since it's a binary classification, I'm using a sigmoid. It acts the same like logistic regression. So that's why I'm using this sigmoid. So like this, I build my model. Then after, we need to compile it. Since I am expecting accuracy, I'm expecting to see the accuracy. We need to compile our model. So how can we able to compile the model? Just write the model.compile command, and in this compile, we need to specify the metrics like accuracy. If you provide this, then it can understood. Like, so while training our model, we need to check with this matrix. Like we need to evaluate the data set with this accuracy matrix. So like that it will assume. Then we also need to specify two more parameters. Those two are, one is a loss. This loss parameter we need to provide, and optimizer. We also need to provide optimizer parameter. So what does these two represents? Optimizer is nothing but for different classifications, different optimizers are used. Basically, these optimizers are used to adjust our weights or parameters of our model to make our model work efficiently. The parameters are adjusted based on the optimizer that you select. This ADAM is nothing but adaptive optimizer. So that's why we are using it. It is an advanced based optimizer. This is best for supervised or almost all ML based models, like for classification you can take, or for regression you can take. For those two, this is the advanced model that we need to prefer because it can able to optimize the parameters based on the model that you select. So that's why we are using this advanced model where it is having all features included. So that's why we're using it. And loss. So here we have multiple losses are there, like mean square error is one of the loss. And since this is a classification based task, so since it's a classification based task and not related to image, we are using binary. We're using binary cross entropy. We will actually prefer the other entropies, like we also have parametric cross entropy that we actually prefer when we have image based classification, and here we will use whenever we are having multi-class classification. Let's say if we are doing not classification, we are doing regression, then during that time mean square error based loss we will prefer, or mean square absolute value we will prefer. So those two losses are there. So since this is a numerical, or you can say text based classification, so that's why we are using this binary cross entropy. So that's about the loss. In order to indicate the loss, calculate the loss. So that loss also be displayed after doing this. You can see this is how the result will be. You will get the accuracy as well as the loss after performing this. Now we need to train our model. So let's see how to train the model. So in order to train the model, we need to fit whatever the inputs we have, like training input features as well as the output features. Training output features we need to provide while training our model. So let's provide the things like model dot fit is the function that we use to fit or train the model with input features as well as output. For those input features, particular corresponding output. So x train is nothing but the input data set, and y underscore train is nothing but the output data set. So these are the must and should parameters. You just these are the must and should parameters, and apart from these, we can also need to specify some more parameters like epochs. So what does this epochs means? Epochs means the total number of cycles. The total number of cycles that our model will be trained with this data set. So the total number of cycles our model will be trained is defined by using this epochs. Then we also need to specify the batch size. So what do you mean by about batch size? If we pass any input, like here in training dataset, like we have how many records? Some 800 change, or so like that we have records, right? Yes. So those many, among those many records, how many, what is the batch size of records that are passed to this model at a time while training? Let's say I have 32 records, and now I'm defining this batch size as 16. Then what happens is, so totally 32 records, right? Yes. So first 16 records, 1 to 16 records will be sent for the first time while training, and 16 to 32 record. All the next 16 records will be sent for as another batch. That is, this whole 32 batch of data is divided into two batches. This 32 records is divided into two batches. One batch will be sent first time, and second batch will be sent second time for the training. And each and every batch is trained for 50 number of epoch cycles. For the 50 number of epoch cycles. Then we also need to specify, since we are expecting to see the accuracy, we also need to specify validation data set size. Validation split. So this parameter also we need to specify. This parameter will tell the model that in provided data set for training, how much percentage of data is used for validation, how much amount of data is used for validation, other than that data is used for training, and how much amount of percentage that we specify here, that much amount of data is used for validation. So while validating, what are the metrics that we selected while compiling, that matrix and that particular loss and that particular optimizer, so these configurations are used. So while training as well as you can see while validation as well. Here 0.2 represent 20% of the validation split data set. Nothing but our validation data set is 20%, and the training data set is 100%. The training data set is remaining 80%. This is the training data set that we provided. If you assume this data set as 100%, in that 100%, 20% of our data set is used for validation purpose related to this matrix, this loss. And for training, by using this optimizer algorithm, by providing specific parameters which are suitable or which are adjusted by using this optimizer, we are using the remaining 80%, data or 80% records in it. Then in order to display the result, we have verbose command. So for this verbose, we have 0 is there, which represents no output is displayed. 1 represents a bit related output, like this. So like this, a bar related output. You can see like this, a bar related output will be shown to us, and their accuracy, losses, and their corresponding values will be displayed. Whereas if you provide the highest value than this, like a 2, then what happens is it will show each epoch cycle or each training cycle related detailed report it will provide. Currently, I just want this bar as well as this accuracy loss and value accuracy and value loss of each and every epoch cycle. You can see So for each and every epoch cycle, those values will be printed. So if you use this verbose is 1. So then after at last I am also expecting to see the value. So till now the validated data set is used. While training itself, we are validating our data set. We are providing our validation data set as well as training data set to our model. Based on the validation data set, this matrix, that is accuracy, is measured and we'll get the response. After training, now training is done. I'm storing this training in one of the variable like history. And after training, I want to perform evaluation. So if you want to do evaluation of the model, then so it's also very simple. We need to select the model, that model dot evaluate of. So what is the test data set? That is x test comma y underscore test. It's nothing but the expected output, and this is the provided input for testing. So that data will provide us the accuracy as well as the loss. For test data, whatever the loss I'm getting, that I'm storing. For the test data, whatever the accuracy that I'm getting, that I'm storing. And so at last I want to print the accuracy of my test data set. So I'm just printing the test data set accuracy in the form of float values. So I want to use a formatted string to provide a value in between these flower braces. So here I want to print the test data set accuracy. So I'm writing that test underscore ACC, and up to 0.3, up to 3 floating values I require. That's it. So that's why I'm printing like this. Now I'm just rerunning this. So first I want to clear this, and I want to rerun this file since I've written the code. If you run this file, then what happens is, so first while training our model, it will provide us this matrix related to validation data set. After training our model, the test accuracy will be provided based on our data set, that is a test data set that we provided. This validation data set, from where we get this validation data set? From the training data set itself, we provided. Consider 0.2% as validation. You can see validation results are getting like accuracy, loss, and value accuracy and value loss. So these all data we are getting for each and every epoch cycle, that is 39, 40, 41. So like this, totally 50 epoch cycles we specified. So that's why for 50 epoch cycles, we are getting these results, right? Yes. Then at last, we also got one result. These results are related to what? These results are related to this. We consider the test data set and we are evaluating our model by providing the test data set, and we find the test data set accuracy, that is nothing but 0.821. But the actual accuracy is this and actual loss is this. Since we printing only 3 values, so that's why the round off for 0, 9 is nothing but 1. So that's why here 1 is came. So like this, actually we can able to do evaluation of our model. So what we have seen how to build the model, and we have also done like compiling for the matrix, that is accuracy. And while training itself, we consider the validation data set, and we have seen the loss and accuracy matrix for this validation data set for each and every epoch cycle while training. After training, our model related evaluation based on testing data set also we have seen, and we have seen the accuracy after testing our data set as well. Now let's finish this by testing this to predict some output. Like we will predict the output from this trained model, from this trained neural network based ML model. We will pass some input to this, and we will predict whether this trained model can able to say whether the person can able to survive or not based on the accuracy that it, or based on the value that it provides. So in order to pass some input to this model, we first need to understand how the data we pass it to this. This is the actual test data. So let's see how the test data will be, and we have even normalized the data, right? Yes. So let's first see how many columns of inputs that we provided, and we will design such type of input to predict the person can able to survive or not. So that's why I'm printing this to check what are the columns that I need to provide as input for checking whether the person can able to survive or not. You can see these are the columns I need to provide. So totally how many? 1, 2, 3, 4, 5, 6, 7, 8. So totally 8 columns I need to provide. So let's take the input values list. So input list, let us consider the input list. So what input list I need to provide? That is nothing but a list of these 8 values. What is the first value? P class, person class. Nothing but the third class only, let's consider, and age, let's consider 10. And SIB, SP, let's consider it as a 1. And this let's consider as 1. And fare, let's consider the fare as a 20 rupees. And the easy mail, yes, true. And the embarking queue, let's consider it as a false. And embarking S, let's consider it as a true. We generally provided a random data of input. So like this, we provided total how many columns? 1, 2, 3, 4, 5, 6, 7, 8. 8 columns we provided, right? Yes. So as per the tested data, we provided we created our input list. Then after how we trained our model? We trained our model by standardized scalar data set. After normalizing only, we trained our model, right? Yes. So while testing also, we passing only the normalized data. Now let's normalize this. So how do I can able to normalize this input list? Normalized input list. Normalized input list is nothing but, so as in a similar way how we done it previously, we just previously created this scalar. From this scalar preprocessing, let's use that scalar. So in order to transform that data set, so simply write scalar dot transform of, so whatever the input that you want to provide, that list we need to provide. Yes. So this is the input list. Now I want to use this list and pass this list to my model and predict the response, like whether the person with these details can able to survive or not. So in order to pass our data to our model, first we need to load this list as this normalized list as a numpy array. So in order to load this as a numpy array, I'm just importing numpy as a np, and sample data I'm taking as np dot array, which represents a numpy array of. So whatever the normalized list is there I have, so that I'm providing inside a list. Inside a list, I'm providing that normalized list. Then I want to do prediction. So in order to predict, in order to get the prediction from our model, I'm just using the model dot predict command to get the prediction. So for what data we want prediction? For the sample data that we just now created, new sample data that we just now created. This will provide us the prediction. Let's print out the prediction value. So based on the prediction, we can able to define whether the person can able to survive or not. Now I'm just rerunning it. What happens is our model will be again trained, and based on the given data set that we provided, that is nothing but the Titanic dataset. Then after it will be compiled, and we'll see the accuracy of it in 50 epoch cycles, and we also see the evaluation metrics like accuracy. And at last we are predicting the output by providing some sample input to it. So let's observe how the predicted value will be. You consider it to 0 or 1. I think expected a 2D array but got a 1D array instead. I think here we need to provide a 2D array instead of a 1D array. And let's check it again. So for the input we provided 1D array. So that's the mistake we got right now. The input we consider round off to either 0 or 1. If the value is greater than or equals to 0.5, we consider it as a 1. That is the person can able to survive with this data. If the data is less than 0.5, then we can consider it as a 0, that the person cannot able to survive. Based on the prediction, we can able to define whether a person can able to survive or not. So still there will be some mistake is there. Expected 2D array instead of 1D array, where we provided the issue here is, I think here we provided the wrong spelling here. And one more thing is this normalization. Actually we will done this normalization on this layer, that is whatever the sample data that we have, on that we will do this normalization. That is, this is the input list that we want to use, right? Yes, by using that input list, here we are creating a sample data set, and we are passing that data to our model to predict. And while passing the sample data to our model, here we can able to normalize the data as well. So whatever the scalar dot transform method that we use to normalize this data set, that we can able to use that method here as well. Before using the response, so you can see how the response will be, how the predicted response will be. After transforming also, the data will be normalized. So that's why it is very becoming easy to predict the response. Yes, you can see. So it is the response will be greater than 0.5. So that's why the person can able to survive based on the prediction. If let's print the direct output, like if the prediction value is greater than 0.5, then let's print survival. Else case, not survival. And yeah, let's comment this prediction as well, or else you can print the prediction so that you can able to observe. And while passing the sample, you can able to perform like a normalization, whatever the scalar that you implemented previously, that we actually need to implement here on the sample data set. After creating a numpy array, we not implement it here for the directly to the list. If we do that, then whatever the error that we encounter here, like that error we will get. So while passing the input, just consider the input. And so in order to pass the input directly to your model, first create a sample data set. Like by using a numpy arrays, you need to pass your list in the form of a numpy array set to your model. So that's why we created this numpy array. Then we are transforming that to, or we are normalizing that sample data set and passing to our model. Even we not normalized it, that's not an issue. We normalize, yeah, after normalizing, we're getting some different response, right? Yes. Since we are considering the normalized data set, we need to consider that as well. That only after normalizing as per the value that is 0.49, that means it's not survival data. Nothing but the person cannot able to survive. So like this, you can able to transform the data, and you can able to predict whether a person can able to survive or not as well by providing your input like this to your model after training. This is the trained model that you trained on top of a Titanic dataset. Yes, survival. You can see survival. We will get the result as survival. So this is all about building your model and compiling your model, training your model, evaluating your model, predicting the output based on the given input. This is the overall implementation of your deep learning using a neural networks. That is implementing your ML models by using a neural network. First, we pre-processed our dataset, then we build our model, then we trained our model with that pre-processed dataset, then we evaluated our model with the test dataset, then we predicted the output, then we used the model as well. So that's all about this video. I hope you understood this video and you got some knowledge from this video. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye.